Thank you so much for having me. I'm going to talk a little bit about what we do at Grass, some of the problems we're solving, some of the exciting things we've got going on. And yeah, let's get into it. I like to start these with a few just kind of general statements about the scale of the problem that we're solving, just because every time I look at it personally, it's kind of mind-blowing. So yeah, 2.5 quintillion bytes of data are created every day. That translates to about 6 new websites every second, in addition to all the data that's being populated on all of the existing websites around the world. And there's all this data on the internet, but the internet itself, it was built for people to access, not necessarily for machines. What I mean by that is most of the people hosting all this data on these public websites, they're creating it with the intention of having people, humans, go and access those websites and access that data, not necessarily for algorithms or robots or machines. So what ends up happening is you have an internet right now where all the machines and the AI crawlers and the AI models that are trying to retrieve that data, they're being blocked out. The most common way that's happening right now is actually all the data center IP addresses and all the known IPs of AI crawlers are being blocked explicitly by these websites. So just taking a step back now and talking about AI, and I promise I'm going to kind of wrap this all together. But this is the OpenLLM leaderboard. It's a bit outdated, but the trend line that you're seeing, the one that's basically flat, has continued since then. What this graph is showing us actually is that a lot of the text-based AI models have started to plateau in terms of their ability. And what people have realized over the last almost a year now is that you can't just infinitely throw data and compute at the same algorithm and just infinitely have it continue to become better. One of my favorite analogies was a guy that made the joke, oh, my baby doubled in weight in the last 3 months. If I wait another 3 months, it's going to double again, and by the time it's like 10, I'll have a world record and I'll break the planet or whatever. I thought that was really funny, and I thought it was kind of interesting that a lot of people a year and a half, 2 years ago, were using this type of logic to explain AI scaling. It's really not the way we should be looking at things. So what's really accruing value in a world where these AI models are all kind of saturating in terms of their ability that's derived from scaling? Like, how do we make them better? The answer is very simple. It's giving them net new knowledge, right? We're finding that all the places where AI is finding PMF, there are areas where we're able to give AI models really good context. Most of the time, that context is net new knowledge that wasn't present in the AI model's training set. So if you want the model to be useful, you've got to give it some data that is net new to it while you're prompting it in order for it to go and derive some kind of actionable insight from that data. And yeah, I just think this is kind of an interesting graph to show. You can kind of get an idea of how much of the internet is really being absorbed by these AI models right now. It's an insane amount. And by 2028, the idea is that the entirety of the internet will have been used to train AI models. And this is just from training, right? It's like the recurring theme I'm talking about is brute force scaling has its limits, right? We have to find other ways of improving these models, making them better. And the answer just kind of keeps coming back to giving them better context. So let's talk about Grass in particular. I put some scary headlines on this slide. The way Grass actually started was because we wanted to solve an ethical problem in web scraping. My co-founders and I, we had backgrounds in cybersecurity, web scraping infrastructure, high frequency trading, real-time AI, things like that. And we were pretty well versed with the way that any algorithmic scraping of the web was happening. And the way it was happening was people had to use non-data center IP addresses to access websites. What's a non-data center IP address? It's a residential IP address. How do you get millions of those? A bunch of the internet guys here, they know that IP space is actually limited on the internet. The internet was kind of poorly designed. There's only an upper limit on how many IPs you can put on it. So they're pretty valuable. And all the ones that are residential, most of them are actually being hijacked by really big companies that are using people's residential devices to scrape the web and not paying people. And most of you have installed a free VPN, like NordVPN is one of them. You've probably got a Roku TV, and if you've got a screensaver on that Roku TV, that screensaver is probably also a web scraping bot. And companies are using your device right now to scrape their competitors' websites with your IP address because their competitor's website is blocking data centers. And they also want to see their competitor's website in your geography. Or they're an AI company, and we all know why AI companies need that data. So the idea was, why don't we build an opt-in network that anyone in the world can join? You go and install something on your device, and you get directly rewarded for it, not just monetarily, but also you also get a bit empowered, right? Because you get to own a piece of the network that you're contributing to. And we found that to be a really good incentive mechanism for having it kind of self-propagate and have people refer their friends and stuff. Like, you can't really get that if people don't really get to own a piece of it. So I just said this. So the way Grass works now is, like, we have a few million nodes on the network. Any company in the world is now able to plug into our network and access the websites that they need. The way that we're actually interfacing with a lot of companies right now, the vast majority of our customers are big AI labs and also small AI labs, I guess. We've decided to verticalize, and because it was just the largest market opportunity, we've been focusing mainly on AI applications of this network. Yeah, we've got millions of real users. We have reach all over the world in over 190 countries. I say over 190, but I think there's weird politics around counting countries, so I'd never say an exact number. And we do have real revenue. The Grass Foundation, in order to align incentives with token holders, is the one that takes all revenue coming into the system, as opposed to the labs entity. So labs entity is just research and development and building stuff on behalf of the foundation. Grass Foundation is this custodian of the token and is currently taking in a few $1 million a month in revenue. So what do we have kind of coming up on the horizon for Grass? This is, I think, probably the most exciting stuff. We have a storage network, actually. So we scrape, for those who aren't aware, we've been scraping over a petabyte of data per day for months. 100% of this is demand driven, so you can't just turn it off. But that data has to go somewhere. And we found that paying cloud storage providers was kind of becoming insane. It actually got so crazy to the point that some of the publicly traded cloud storage companies started bragging about working with us in their earnings calls. And that's when we knew, hold on, there's got to be a better way. So one of my co-founders and our CTO, Chris, took it upon himself to personally design this data center infrastructure, locked himself up in a data center in Ashburn, Virginia, where we bought some space, and racked all the servers and slept on the ground with the team, and it was insane. We got that up in 3 weeks, which was awesome. Now, multimodal search. Actually, I haven't really talked a lot about the type of data that Grass is collecting. I think that's super exciting. About a year ago, because we started seeing a lot of text models begin to saturate, we figured, where will scaling laws really manifest themselves next, if not text? And the obvious answer to us was multimodal data. By that I mean video, audio, text, stuff like that. The biggest companies in the world 6 months ago that host multimodal data started blocking data center IPs. And we already had everything up and running for it. So it was a really easy switch for these AI companies to just come and work with us. And that's been working out really well. That being said, though, we're starting to see demand from outside of AI, namely robotics companies, some ad tech agencies, stuff like that, who also want to access this multimodal data, mostly the videos. However, they can't really afford to buy the entire data set the way some of these very huge AI companies or hyperscalers are doing with us right now. So instead, in order to help curate data for them and reduce the number of man hours that go into curating specialized data sets, we're automating the process. So we're currently building the largest multimodal synthetic data set in the world, probably. We're annotating the frames of 1 billion videos one by one, embedding them as well, and creating an entire index out of it that anyone in the world can access. And that's probably about 4 weeks out from launch. It'll be our first public-facing data product that anyone in the world can just interact with. So personally, extremely excited for that, and the team's been killing it, pulling all-nighters to make this happen on time. So I can't wait to share more about that in the future. And live context retrieval is kind of the end game for us. I keep saying like context is important, and I really mean it. Think about it this way. There are two internet scale web crawls that exist in the world. One of them is Bing. We all know the other one. Starts with the same letter as grass. The other one doesn't, they don't have an API, but Bing has an API. It's $10 for 1,000 searches. And if we think about how we're going to access the internet 5 years from now, it's kind of silly to think that most of the billions of people on the internet are not going to be using LLMs to automate things for them. They will be using LLMs to automate stuff. And those LLMs will need access to the internet. They'll need a way to search the web in a way that's not optimized for clicks, but rather one that's optimized for semantic similarity. And that's what the idea is behind live context retrieval. We want to turn the entirety of the internet into a massive API call that any LLM in the world can use. So you can think of it as like a search engine specifically built for LLMs. And actually, OpenAI is trying to do the same thing right now. But they can't because they don't have millions of residential IPs. There's an excerpt from an article on Bloomberg where someone from OpenAI was talking about how they want to build a web index because their models are suffering from hallucination, and the only way to make them better was to give them access to real-time context. But they weren't able to. They weren't able to do an internet-scale web crawl and actually rely on it properly because too many of the important websites were blocking their crawler. And they need the ability to rotate IPs. And this is, very luckily, something that Grass already has built in. And we'd be really, really stupid not to chase after this opportunity with everything we've got. So, I should have reordered these. I threw in a picture of how knowledge graphs work, because that's kind of the architecture behind what. And I didn't make this. I took it from the internet. I forgot to put the credits. So if someone who made this is watching, I'm sorry. Comment on the video or something. But yeah, the way knowledge graphs work is it's a way of organizing information such that you can actually see the relationship between different knowledge units. We've designed live context retrieval in-house, and right now the big limiter is getting more nodes on our network. We don't have enough of them. It'll effectively work like this hybrid vector graph search mechanism. So you have all these different knowledge units that have a different connection between each other that say this is how we work. Then we also have, for large scale broad searches, we have all the knowledge stored in vectors so that we can search them semantically. I mentioned earlier, multimodal AI training is just a huge tactical opportunity for us. So it's also, you're going to start seeing a lot of things come out from Grass, and they're going to converge, right? We're going to be putting out this multimodal search, and there's no reason for that to become real time one day. So when LCR launches, the idea is going to be, you're not only going to be able to search for text from anywhere on the web, but an LLM will be able to ingest a photo and search the web with that photo, for example. That's incredibly exciting, and it's something that just doesn't exist yet. And I think one of the most motivating things in the world is just working on a problem where that if you can solve it, it's going to literally grow a market by an order of magnitude. And just to give you a scale of how much multimodal data we're talking, we're doing this today, over a century of multimodal data, over a century of video content in one day goes through Grass's servers, and also through all the different nodes on the Grass network. These last few slides are kind of just fun things. This is the growth of the amount of data we've scraped. There are days where it's just really low. That's because sometimes when really big customers need to ingest lots and lots of data, we have to use all of our compute to do that. That's why we're doing it. And actually, I had to include this photo for Chris because he racked all of these. I think it's incredibly impressive. So because of NDA reasons, weird stuff going on in the data center, we couldn't actually take pictures of the most exciting part. Which is the data gets stored on tape because it's the most efficient storage mechanism. There's actually a robotic arm that one of our engineers is programming that picks up the tape and plugs it into servers as we need to retrieve data. And it happens really quick. It's super impressive. I can believe it. But yeah, it's kind of a cool thing that we're doing. This is This is the quote from our CTO that this public storage provider included in their earnings call. It's the funny thing is during that earnings call, I was like trying to call their chief revenue officer saying, "Hey, reduce the rate limits, dude. Like, stop talking about us and just do that." And yeah, this is kind of a sneak preview of the UI for multimodal training. I think it's just really cool. I gotta give a shout out to our designers. I think they always like come up with bangers, and yeah. Anyways, that's grass. Happy to answer any questions.